Okay, today we are diving into the intriguing world of childhood clumsiness. We're going to explore the mysteries that lie within our nervous system. So if you've ever wondered why some kids seem a bit more uncoordinated than others, then you are in the right place. Hi, my name is Lisa Andy Garcia, and I am an integrative developmental and educational specialist, and my focus is helping you to reverse the learning and behavior challenges that your child or student or yourself are experiencing. So in this video, I'm going to talk about coordination issues in children, but first, please hit that subscribe button so you'll be the first to know when I post a new piece of content, and hit the like button as well. Okay, so one of the main structures that is involved with coordination and balance would be the cerebellum. It's located in the back of the brain. Okay, when you see a brain, there's like these little two bumps in the back. That's the cerebellum. It's often referred to as little brain. We've talked about it before in other videos, but it plays a crucial role in muscle tone, in coordinating movement, maintaining balance and posture. When there's a glitch in this system, it can manifest as clumsiness. The cerebellum, it receives input from the sensory systems and the cerebral cortex to coordinate the movement. So its job isn't to initiate movement, its job is to smooth it out and make it nice and smooth and coordinated and rhythmic. And it helps maintain equilibrium, which is balance. It is deeply involved in motor learning. It allows us to refine and improve motor patterns. So again, it doesn't initiate the movement. That is done in the motor cortex up here. This is the initiation, but the smoothing out of the movement is done in the cerebellum. And also the frontal lobe and the basal ganglia are other areas that help initiate movement and are involved in movement, but the cerebellum just smooths it out. So if the movement is uncoordinated, then there is an issue with the cerebellum. So the roles of the cerebellum are motor planning and execution. So it receives input from various parts of the brain, including the motor cortex, and it integrates this information to plan and coordinate movements. It's involved in precise timing and sequencing of muscle contractions needed for smooth, purposeful movements. Feedback control. The cerebellum continuously receives sensory feedback from the muscles, joints, and proprioceptors throughout the body. It compares the intended movement as signaled by the motor cortex with the actual movements, which is known as sensory feedback. It allows for real-time adjustments to achieve accuracy and coordination. Then we have balance and posture. The cerebellum is essential for maintaining balance and posture by processing sensory input related to body position and orientation, makes constant adjustments to counteract changes in the body position. We have muscle tone regulation. It does this by adjusting the activity of motor neurons. This regulation is crucial for the appropriate resistance and support during movements. It also coordinates limb movements. This is particularly important for activities that involve complex and coordinated movements, such as playing a musical instrument or typing. It's also involved in eye movement control, and through connections with the brainstem and cranial nerve nuclei. Learning and adaptation, and we have error correction, we have timing and rhythm. Okay, so these are all the different things that the cerebellum can do or is involved in, and there's actually more that they're learning about, even like the reward system and different things. They're still learning about the cerebellum. It's important to know, really, really important, especially if you're a parent, even a teacher, that gluten has a particular affinity to the cells of the cerebellum, called the Purkinje cells. And they have an autoimmune effect, or gluten ataxia, causing issues with coordination, among others. So if you have a problem with coordination, could be the gluten affecting the cells in the cerebellum. So that would be an easy fix, to remove the gluten. I mean, I know it's not easy to remove gluten, but then, you know, you don't have to do a lot of rehab, right? So, but gluten definitely can affect the cerebellum. The vestibular system is also involved in planning and movement. That is located in the inner ear. Those in there look like three little labyrinth little tubes or whatever. And the vestibular system contributes to our sense of spatial orientation and equilibrium. So here's how the vestibular system helps with coordination and balance. Through sensory input integration, it receives input from the semicircular canals, which is what I was trying to say those three things. I was like, couldn't think about it. Semicircular canals. It detects rotational movements and it detects linear acceleration and gravity. So it has these different components and it does that. They also provide continuous information about the body's position and motion in relation to gravity and the surrounding environment. It is also involved in postural control, so the vestibular system works in conjunction with the visual input and proprioception, and sensory input from muscles and joints to maintain postural control. It helps regulate muscle tone and adjust muscle activity to keep the body in an upright position against the force of gravity. It also is involved in eye movement stabilization. So that's it stabilizes the eye movement during when the head moves, the eyes are stable, and that's known as the vestibulo-ocular reflex, the VOR. It ensures that the eyes remain fixed on a target even when the head is in motion. I mean, if you really think about it, you know, like, have you ever seen anybody take a video and it's like this and you're like all dizzy? Well, if you think about it, you should be seeing life like that, but you don't. You see life steady even if you're running. I mean, imagine that. This stabilization prevents blurry vision and helps maintain visual focus during activities like walking or running. It's also involved in spatial orientation. The vestibular system provides information about the body's position and orientation in space, and balance during movement, adaptation and compensation, spatial memory. Okay, so the vestibular system is also super important in spatial awareness, visual system. It even has to do with muscle tone, believe it or not. And so we'll talk about vestibular system in a whole nother video. So we can see that there are a lot of overlap between the cerebellum and the vestibular systems. And in fact, the vestibulocerebellar pathway, so that is a pathway from the vestibular system connected to the cerebellum, is a communication pathway that is specific for balance and eye movements. So if your child or students are experiencing issues with balance and coordination, then doing activities that support both the cerebellum and the vestibular system is very important. So activities for the vestibular system would be anything with motion, especially spinning, rolling, swimming, swinging. You have to be careful because if your child is sensitive to motion, then you want to present them in very tolerable bits, very slow, very little tiny bits, very slow. But you need to do it in order to build up the tolerance. Some kids, like mine, could go. They can spin till the cows come home and nothing affects them. And so that's the other opposite end of not being good either. So with these children, so what they should do is when they're spinning, if they're on a spinning board, I have a spinning board. I should show you one day. We'll do a whole thing on vestibular, but when they're spinning, if you spin them hard and fast and until you get tired, then eventually in about 2 weeks' time, they will start to build up tolerance. These are for the kids who spin by themselves, who never get dizzy. When a child spins or anybody spins, after a certain amount of time, when they stop, their eyes should move. That's called post-rotary nystagmus. That's PRN. And if their eyes don't move, it means they're underactive, that they need more of it to activate it. So after the 2 weeks, they can develop that PRN. But for the opposite spectrum, if you have kids doing like pencil rolls and they're not used to rolling, they could literally they can have a headache for the rest of the day. So you have to really be careful with spinning. To support the cerebellum, do things that challenge balance, such as standing on a wobble board, walking on a balance beam, walking with one foot in front of the other while trying to touch your nose or the tip of his finger, or walking while bending their head, looking up, trying to walk on a balance beam. Or, when I say balance beam, I had one that was like this high off the ground, so if they fell, it wasn't. I don't mean like a high balance beam. But like a board or something that just where they have to balance a little bit. In Japan, I would see kids walking on top of a fence. They would just, like an iron fence, they would just be walking. They do a lot of things with balance actually in the Japanese schools and in their playgrounds. They had stilts. They had all kinds of things that challenged their balance. Oh, unicycles. Unicycles is like all the Japanese schools, everybody, that was a big thing. So for us, they would come to our school on Culture Day and it would be like, oh, wow, how can you do that? But unicycles is just kind of a thing. So they do a lot to challenge balance. And anything that challenges movement in general will help develop the cerebellum. Any complex movement, anything that's, literally the classic tap your head and rub your stomach, anything that's movement, maybe that uses both sides of the body, that's challenging, then that is developing cerebellum. Whenever a movement is challenging, your cerebellum is working. Whenever the movement is automatic, it has moved up to the basal ganglia and the cerebellum is no longer working. So the cerebellum is active and lit up when you are challenging the movement. So if you would like to know more about how to support someone in your life struggling with coordination and balance issues, you might be interested in Bloomberg Rhythmic Movement Training, which is a primitive reflex integration course. You can click the link below in order to learn more about that. Otherwise, I put these videos out on Monday. On Wednesdays, I put out a tips and tricks. And so I hope that you remember to subscribe, to like this video, so you are able to be notified when my next videos come out. Bye.